Hi, this is John with Somerset Consulting. Today I'm going to talk about the history of Windows device drivers. So this is an article I wrote many years ago actually for one of my clients as part of a project. And basically this document here, which is also on my website, covers the evolution of Windows. All the way from, I'm going to read here from the table of contents. So it starts with MS-DOS 1.0 and the device driver technology is used there, and also went up to DOS 2.0, and then of course Windows 1, 2, 3, Windows NT 3X, Windows 95, NT4, 98, second edition, Millennium Edition, 2000 XP, Vista 7, 8, 10, VXD drivers, Interstell drivers, WM drivers, WDF drivers. That's pretty much where it ends. So the idea then is that to document the evolution of Windows drivers from the beginning to today, so you get a good overview of where we came from on the modern platforms. So starting with MS-DOS 1, I'm not going to read the whole thing here because it's kind of tedious, so I'll refer you to below. There's a link to a PDF file which essentially explains, well, it's the same document as I'm holding here, so just download it, take a look, and I'm just going to give you the broad overview so you can determine whether it's worth downloading and looking at. So MS-DOS 1 basically had only one type of device drivers. Those were resident device drivers compiled into the operating system. There's no way of expanding it, except if you were an OEM hardware developer. Then you could buy something called an OAK, OEM Adaptation Kit, which allowed you to actually link your own drivers into the object files delivered with the system. MS-DOS 2 came up with installable device drivers. So there are a couple of versions of it. There are block devices and character devices, and that's something that you didn't have to have the OAK to install drivers and create drivers for your own hardware devices. Also, installable devices on DOS 2, that's when you started seeing the device equals xsx.sys. And that's the way you then tell the operating system, the standard operating system, to load your custom driver. Windows 1.0, of course, was a graphical application running on top of DOS. So it wasn't really a Windows operating system, it was simply an application. So that's the famous non-overlapping windows you might have seen in Windows 1.0. You can look it up on the web. Quite amusing today, but that's how it all started. Then of course, because it was just an application on top of DOS, you had the infamous 640 KB limit on memory. And drivers simply talked via in and out instructions to the hardware. And of course, no protection between applications since there was only one application running. It's MS-DOS after all. Windows 2.0, the main difference was that it supported the 286 CPU, and that of course gave Windows applications access to the new protected mode and 16 megabytes of memory, which of course a big step up from the 640K plus some upper memory blocks in MS-DOS. Okay, Windows 3.0. I'm not going to talk much more about Windows 2. Windows 3.0 was a major release, of course. The difference was that finally the 386 CPU was supported, and of course the main feature of the 386 compared to the 286 was that you now have a complete 4 gigabyte virtual address space for each 32-bit application running, and that was a huge thing, if you recall, and you were there in those days, because that meant that you have kind of VAX capabilities on a microprocessor, and that's a big thing, of course. So then you had multitasking. However, there was only cooperative multitasking by 16-bit applications. Windows 3.0 was not a 32-bit application operating system. So that means that all the 16-bit applications, they had to share one 4 gigabyte address space and hand off via the message loop then control to the other applications, so they can kind of go in a round-robin fashion. And of course, if one application misbehaves, the whole system locks up. Also, one thing in Windows 3.0 which was a novelty was the use of VXD device drivers, or virtual device drivers, and those were introduced in order to have the huge install base of MS-DOS application think that they actually executed on their own machine. So the way that worked was that whenever an application tried to access an in or out port, for instance, and touched hardware directly, the operating system would trap that and pass control to the VXD, then that would virtualize the device. Basically save the state of whoever previously used it, let that application use it, and then restore the state. Then let's see what else. That's pretty much it. Windows 3.1 introduced in '92 improved performance a lot by removing a lot of the real mode MS-DOS and BIOS routine calls that the operating system used with 32-bit VXD drivers running in protected mode on a 386. And of course, that's a lot faster than going through the old legacy BIOS and DOS calls. And still, there's a lot of dependency on MS-DOS and BIOS for disk and file I/O, and that's something that was removed in '95 later on. Windows 3.1 also had the Windows for Workgroups, if you remember that, which was essentially Windows 3.1 with networking. And then you had support for some multimedia started coming along with AVI and Wave support, and introduction of DirectX later in Windows 95. So now the interesting things started to happen in early '90s. That was, of course, when Microsoft started development with Cutler in charge of developing Windows NT. And in '92, Windows NT 3.1 was introduced. Of course, the reason it was called Windows 3.1 was because Windows 3.1 was very popular, and NT, I assume they wanted to name it the same. So that, of course, has a huge internal differences from Windows 3.0. NT has preemptive multitasking, full multi-threading, virtual memory networking, completely robust 4 gig address space, kernel mode, and user mode separation, and so forth. NT 3.1 is also completely written in C, because they wanted to port it to a bunch of different architectures. There used to be Alpha, MIPS, and PowerPC supported as well. Now I believe the only one is really x86, and x64, of course, now supported. Still, you could run DOS applications in VDM, virtual DOS machines, which essentially is a that's actually hardware supported feature of the CPU. So you can load all the software that would run inside a legacy PC with a x86 PC, that is, multiple sessions inside one 386 CPU, and then the CPU would virtualize it, handle exceptions, and pass it on to the operating systems. Of course, Windows NT does no longer use VXDs for virtualization. Instead, it uses the NT-style driver built into the operating system. VXDs are no longer supported. You can also run legacy Windows 3.1 16-bit applications using the WoW Windows on Windows subsystem. And that is essentially one single process with 4 GB address space in which all 16-bit Win16 applications execute. Windows 3.1 has the same GUI as Windows 3.1, and then you had Windows 3.5 and 3.5.1, which was basically feature updates to NT3. Now, Windows 95, of course, introduced in 95, was, of course, the first Windows operating system that most users saw that was a 32-bit operating system. And with that comes, of course, preemptive multitasking, and new applications, of course, were written in C to the Win32 API, which has then a protected memory model with one 4 gig virtual address space, and no funny segmentations that you have to handle in your code with limit registers and so forth. All that is gone. It's one flat 4 gig address space, which I liked a lot because the previous programming environment was not really very nice. Also, you are no longer reliant on the MS-DOS and BIOS for disk and I/O and file I/O. Now they have 32-bit VXDs inside Windows 95. And just to clarify, NT, no VXD, Windows 95 in large extent was based upon the previous Windows 3.1. So under the covers, it was actually old Windows 3.1, but they put lipstick on the pig and essentially put a 32-bit programming environment on top of the 16-bit operating system under the cover. So really, underneath there are a lot of 16-bit code. They were doing thunking between 32 and 16-bit VXD code and application code and so forth. But Microsoft was working towards creating a full 32-bit 32-bit Win32 operating system. So essentially they then changed the programming model as well for creating these virtual device driver or VXDs. So it used to be assembly call interface. You put parameters in the register, pass it on to the system does something, I/O for instance, and then you get some response back in another registers. They changed that, or in addition, they allowed you to write VXDs in C. So you have a C callable interface. You essentially pass parameters on the stack, and you push them and call and get a response in the register. And then you had some limited support for USB in OSR version 2, OEM service release 2 of Windows 95. And also you had a DirectX introduced in Windows 95. And that was, of course, because Microsoft did not want people to touch hardware directly anymore. Essentially, previously, people, although they ran in Windows, they wanted to get the absolute highest performance. So they would just touch hardware, drop down. And because the virtualization, if you're writing DOS applications at least, you get a lot of exception handling in the system, and that would go through the VXDs. And by creating something called DirectX, DirectDraw, Direct3D, etc., the operating system used special hardware extraction layers, HALs, to go in a more direct way to the hardware. Windows 9 NT 4.0, 1997, essentially NT3X with a new Windows 95 GUI. Same NT-style driver model, which was introduced in Windows NT 3.1. Windows 98 is pretty much the same as Windows 95 with new drivers, but the most different thing about it for kernel mode programmers is, of course, that it supported new WDM driver model, Windows driver model. If you look at all these books I have behind me here, so essentially the stack of books here, this is my old stack. I do this kind of for hobby. This is the original 80, 88, 86 PC, MS-DOS programming, those kind of things. Original DOS, C compiler, very old stuff. If you look at WDM drivers, pretty much this pile here is all about NT-style drivers, Windows 2000, WDM drivers for XP, 7, 8, 10, and so on. WDM drivers is a big deal. That's the big driver model you would most likely use if you want to write a kernel mode driver for Windows NT today. You, of course, as I will explain later here, have the WDF, Windows Driver Foundation, or as they later called it, the driver frameworks. Has a wrapper around the raw WDM driver that you can use to simplify a bit. But anyways, so in Windows 98, Microsoft rolled out the WDM drivers, which are essentially based on the NT-style drivers. So if you want to learn to program Windows device drivers, I would probably recommend to look at the earlier books, which good one is Windows NT Device Driver Development by OSR, Peter G. Viscerola, and a bunch of other books here, because that is the principles in an NT-style driver from NT3, 5, and 4 directly carry over to WDM drivers. So you can pretty much start with the basics and then add on all the more complexities in WDM driver. And of course, if I skip over the rest of Windows 98 here, talk a bit more about WDM drivers, the difference was that later operating systems, starting with actually Windows 98, introduced plug and play and power management. A lot of it was because you had support for USB, limited support for USB in Windows 98 later editions. And that, of course, requires plug and play to discover the device, load the driver dynamically, unload it, and so on. And also power management, you power down the device, which is part of the USB bus design, that you would suspend devices if not being used for a certain time, and so on. Windows 98 still supported the older VXD drivers that went all the way back to Windows 3. But if you want to write new drivers for it, of course, WDM drivers were recommended. And then you had some Windows 98 version 2nd edition and Millennium edition. It's essentially more drivers and applications came with the operating system out of the box. Not going to say much more about 2nd edition. Windows 2000, though, that's of course built on NT technology as well, and therefore it only supports WDM and older NT-style drivers. Windows XP and newer, I would say that most NT versions, or XP 7, 8, 10, are pretty much internally the same as Windows XP, with a difference perhaps from 64-bit additions, although there were XP 64-bit as well. So if you want to start simple, you can just load up a XP system. 32-bit would do just fine. If you want to develop drivers, you can start with NT4 drivers, move on to WDM drivers, and go from there, and then do 64-bit drivers on top of that. Will work just fine. XP is, of course, Windows NT version 6. I'm going to talk a little bit more about VXD drivers, so you get a feel for the difference between the older technology, VXD versus NT-style and WDM drivers. So VXD is a 32-bit device driver running in kernel mode, has assembly or C callable interface. So essentially, you export a structure called the device description block, which defines the functions that can be called in the driver. And also it contains some information about the driver itself. And the operating system then knows what capabilities are available to drivers. It can call in whenever the applications call in. And then essentially I talked about the, like I mentioned before, originally they were written in assembly language because that was the programming language and call interface to the MS-DOS operating system and the PC BIOS. So that was the natural thing. Started in Windows 9X because of plug-and-play. VXDs could be statically or dynamically loaded. Statically, of course, if you put a device line into config.sys, the system would load it when you boot. Otherwise, for instance, if you plug in a USB device and you have a client driver for that custom device, then the vendor ID and product ID of the USB device would then, via an in file, determine which driver would dynamically be loaded. And of course, the same goes for Windows 9.8, but there you would use a WDM driver. NT-style drivers, and those are mainly interesting today because that's the first driver architecture that lends its architecture programming model directly to WDM and also to the newest WDF-style drivers. So if you, like I mentioned, if you want to learn WDM driver programming, just look at the old NT-style books, go from there because it contains a lot less information. And also by going and looking at the past, it's easier to understand the present. So let's see, NT-style drivers essentially is a layered device driver model. So you have in Windows something called the I/O manager. So when you do, for instance, a write file Win32 call, you would pass a buffer down to the operating system. And the operating system then would, via the I/O manager, create something called an IRP, an I/O request packet, which contains essentially the buffer it passes along. An IRP is simply a C structure that's being passed from driver to driver. And drivers can be layered as well in the operating system, so you can have a higher level driver, could be called an intermediate driver, talking to a lower level driver, and then you can have a bus driver in later operating systems. But in NT-style drivers, you essentially have one driver that, while the operating system loads the drivers, and that's pre-configured, of course, in when the operating system starts. It has a list of the drivers that it should load. And the driver then is responsible for probing, for instance, the PCI bus and look for the vendor and device ID of a certain device. And then if it discovers its own device, then it would ask the operating system for resources for that device, which is memory, space, interrupt, and sometimes then I/O space as well. And of course, when you do reads and write, then the system would create IRPs, which are these structures then that the driver would receive, look at the buffer, program the device, get data in and out. That's pretty much it. Talks a little bit here about the difference between the VXD driver and NT-style driver with regards to telling the operating system what functionalities or dispatch routines, that's essentially callback routines, are available in the driver. WDM drivers is something that was introduced in Windows 98, as I mentioned earlier, and that's essentially the main driver type, except for other types, special types like in mini-port drivers for graphics and network cards, audio devices, and special drivers for printers, which use completely different architecture. But the general driver programming model in Windows 98, 2000 XP, Vista 7, 8, 10 is the WDM driver. That's the native driver model. So the difference then from an NT-style driver is that the WDM driver supports plug-and-play and power management. And that actually complicates a lot for the driver programmer, especially plug-and-play, because the device can be removed at any time while you're doing I/O, and that's of course not easy to handle in the driver because there's so many race conditions and states you have to maintain. And that's something that the WDF driver architecture has simplified, so I'm going to talk about that a little bit later. But another difference in WDM drivers is that the WDM driver no longer scans the bus itself, for instance the PCI bus, to find all the instances of its device, like in the NT-style drivers. That's something now that the operating system bus driver does. You have an underlying driver provided by Microsoft that actually owns the bus, and that will scan the bus, find all the instances of all the devices. For instance, look at the PCI configuration space and find all the devices with all the devices on the PCI bus has a vendor ID and a device ID that will be matched to the inf files registered with the system, and then the drivers would be loaded for those particular devices. And once the driver is loaded, then the operating system will assign resources. So again, that's the main key difference, that the driver no longer scans the bus, allocates resources. The operating system does that and hands it over to the driver, to the WDM driver that simply configures the device then. And also it's possible for a WDM driver to have resources reassigned. So that could be that a certain device has some special requirements that requires that other devices give up their resources to give it to that special device, and then have to reshuffle the system. So it could be that your device, your WDM driver comes up, gets resources assigned, and then taken away again, and that's something that you will have to handle. Now, in 2004, because of the complexity with WDM driver with regards to plug-and-play power management, Microsoft created something called WDF drivers, and that stands for Windows Driver Framework, or Windows Driver Foundation, as it was originally called. And the reason it's called Windows Driver Frameworks in plural form is because there are two types of frameworks. You have a kernel-mode driver framework and a user-mode driver framework. So essentially the kernel-mode driver framework is a library, you could say, a wrapper around your simplified driver, and together your simplified driver and the wrapper creates a WDM driver that the system recognizes. And essentially what the kernel-mode driver framework does for you is that it handles, because it wraps your driver, it handles automatically interaction with the operating system for plug-and-play and power management ERPs that come down. So you are isolated from that complexity. And that simplifies a lot. If you want to override and handle it yourself, you can certainly do that by registering callbacks into the KMDF, and you can do that too. User mode driver framework is essentially something that originally was COM based. I'm not sure if too many people remember COM these days, but that was the rage in the late 90s. Everything was COM and OLE, and I got a bunch of books of that, and I was quite into it. And that's of course the reason why Microsoft in 2004, I think, used COM to as the programming interface for the user mode driver framework. And I don't think many people understood COM that well, and I think it caused some problems for driver developers, especially because for driver developers, you want to work in C, you don't like C++ and weird virtual interfaces to figure out how to do iDispatch and inheritance and the querying interfaces and all that stuff that goes on in COM and reference counting. It never ends. So Microsoft revised the user mode driver framework to make a simpler version which has a simpler C calling interface, very similar to the kernel mode instead. So regardless version 1 or 2 of the use-mode driver framework, is that you don't need expertise in implementing client drivers for custom USB devices in kernel mode, that is. You can do it in user mode. And that means that you don't run any risk of crashing the system. Writing kernel mode drivers is really hard. I think that's one of the reasons I kind of gravitated towards doing that over the years, because it's very rewarding, it's challenging, and when you figure this out, it's a lot of fun. These days, of course, you have other ways of writing user mode drivers for USB devices. WinUSB is one example. WDF is, of course, best for writing kernel mode drivers because it shields you from a lot of the complexity, as I mentioned. So that's pretty much a broad overview of the information in this document, and it's available. I have a link below, and you can download it from my website, John.Gulbrandsen, Soft Consulting, and I do Windows device drivers, embedded device drivers, high-speed design, digital design, FPGA digital design, and so on. So thank you very much, and I will later do some more articles and videos regarding drivers and the Windows drivers as well. So I hope you enjoyed this. Thank you.